Okay guys, this is shortest job first with preemptive condition. Now, what is the meaning of preemptive? See, up till now we've been considering an ideal situation where the CPU has uh, all the processes or process control block in the ready queue, and it executes based on whether it's first come first serve or the shortest job first. Now, preemptive means just like in real world situations, a new process may be created at any time. So, accordingly, the algorithm has to adapt. Now, in this case, we see that with preemptive, we have also considered another element known as arrival time, which we did not have before for shortest job first. So, let's say we have this process with so and so burst time, and its arrival time for process 1 is 0, process 2 is 1, process 3 is 2, process 4 is 3. Now we will do two of these sums because this is a little bit tricky, so I want you to pay attention because uh, you need to be able to understand better. So let's put it down here, the arrival time. So let's say P1, P2, P3, and P4, because P1 arrived at 0 milliseconds, P2 at 1, P3 at 2, and P4 at 3 milliseconds. Now, since this is a shortest job first algorithm, so we have to choose again, just like the previous, the job or the process which with the least burst time. If we just look at this, we see that the least burst time is process P2 with 4 burst time or 4 milliseconds of burst time required CPU burst time. Now I've got to tell you earlier that if suppose we have two processes with the same burst time, let's say P2 is 4 milliseconds and P4 is also 4 milliseconds instead of 5. Now if that's the case, then in SJF algorithm, FCFS takes charge, meaning the process which is there first gets the CPU. So if in this case we had P2 4 milliseconds and P4 also 4 milliseconds, we would still consider P2 to run first. Right? Okay. But then the thing here is this. We have to consider the arrival time. Now just by looking at it, you would say using SGF we should run P2 first. But we have to remember that at time 0, P2 does not exist yet. P2 exists from 1 millisecond onwards. So at the start, there's only P1. So we don't have any choice. We have to run P1. So we'll run P1 and we will stop at 1 milliseconds because then P2 comes into the picture and the algorithm has to make a decision. So just so that we don't get confused, let's put another column here, and let's call this finish time, and we see that we have taken 1 second out of P1, so now P1 has 7 seconds at this point. Now at this point P2 arrives and is part of the decision. Now at time 1 millisecond, P2 has 4 seconds, needs 4 seconds of burst time. P1 needs 7 seconds of burst time. And at this time, SJF algorithm works and we see that P2 has a shorter burst time than P1. So P1 becomes preempted. That's why, hence the term. P1 becomes preempted and P2 is given the CPU. So P2 runs for at least 1 milliseconds until P3 now enters the fray, let's say. So 4 minus 1, 3. P3 enters the fray at 2 milliseconds. But then even at this point of time, the algorithms check and it sees that P1 needs 7, P2 needs 3, P3 needs 9 milliseconds, and it's still P2 with the shortest job, so it'll continue with P2 again. So let's minus 1 again. And now at time 3, sorry, P4 arrives. Now when P4 arrives, P4 requires 5 milliseconds, P3 9, P2 2, and P1 7 milliseconds. So it's still P2 with the shortest job. So P2 continues. Now we know that we can still continue because this is, this is the range of our, or the limit or the scope of our queue here. But in fact, in real life, in computers, we have a queue of thousands of processes in line. So it continues until 5. That is when it finishes its execution. So P2 is done, right? Now P2 is done. You can cancel it off. Now we see that the algorithm has to make a decision. Which process does it run next? Does it run P1 with 7 milliseconds, P3 with 9, or P4 with 5? So naturally, it will run P4. So it runs P4, 1, 2, 3, 4, 5, till done here. P4. Now we do not have any other process interrupt. Again, in real world situations, there will be process which interrupts this, and there will be other processes which comes here, but we are just looking at this scope. Okay, so process 4 runs, so 5 minus 5 equal to 0, so process 4 finishes. So next the CPU looks between P1 and P3. P1 needs 7, P3 needs 9, so it will run P1. 1, 2, 3, 4, 5, 6, 7 milliseconds till here. P1. And then it will run P3 with the 9 milliseconds. 1, 2, 3, 4, 5, 6, 7, 8, 9. P3. Right? Okay, so we'll just put that down. 9, 0, 7 minus 7, 0. Here it got 7 seconds. Here it got 9 seconds. So all of them has finish. So let us calculate the average waiting time for this. And that would be P1 plus P2 plus P3 plus P4 divided by 4. Now this is tricky here, because you see P1, at first it did not have to wait, it got the CPU immediately, but then it was preempted, then it had to wait this amount of time before it got the CPU again here. So at first we'll put that 0 there because here it did not have to wait, but then it got preempted here, and then it has to wait for how many? For 1, 2, 3, 4, 5, 6, 7, 8, 9 milliseconds. All right, so this is for P1. It ran twice, here and here. The first time it did not have to wait, the second time it has to wait 9 milliseconds. Now you will say, why 9 when here the Gantt chart shows 10? Because this part it has run, it is actually just this distance. So we count from here, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? Next, P2 began running from here, 1. Right? So you would say that it has to wait for 1 milliseconds. But actually no. Why? Because it arrived at 1 milliseconds. Right? It arrived here. It did not exist here. So meaning P2 did not have to wait at all. Right? And it got the CPU continuously till it finishes its execution. Okay. All right. P3. Now P3 got the CPU at 17 milliseconds. It arrived at 2 milliseconds. So its total waiting time is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 milliseconds. Right? Okay. Now you see P4 arrived at 3 milliseconds, right? 3 milliseconds, and it got the CPU at 5 milliseconds. So it had to wait 2 milliseconds. By 4. Okay, so if we add this all up, this gives me 26 by 4. So the answer is 6.2 milliseconds. So the total average waiting time in this shortest job first preemptive algorithm is 6.2 milliseconds.